Hey everyone, we're going to do another session of pairing on Advent of Code. Today we're going to do day 13. Today I'll be typing and Carol will be providing valuable input along with our cat, Baby, who is very excited to be here. All right, let's go to screen share. Okay, so close that. All right, day 13, maze of twisty little cubicles. So we both read over this a little bit. The general idea is that you're stuck in a cubicle farm, and to determine where walls are, there's a little formula here. And you use that formula, some puzzle input based on the result. If the number of ones are even, then you can walk there. And if it's odd, you can't. Then there is an example of printing out an example here. And the idea is that you need to figure out the maze and go from a start position to a target position. Okay, so how would I start?
I don't know. My first question is, are we going to print out the maze like that to be able to look at it?
So one thing I was thinking while reading over this is that we don't necessarily have to build the whole maze. We can kind of lazily build it because we have an algorithm to figure out if a wall is there or not.
Okay.
And so at each given step, we can say, is there a wall to the left, right, up or down?
Okay, that's interesting.
So I would want to not necessarily print it out unless we actually had like 3 states of don't know if it's there or wall or whatever. So I would probably want to try not having that to start with.
Okay. How much do you want to bet that
that's the
second part is printing it out?
The reason I don't think that that'll be the second part is because they have this answer box that's been basically a single number most of the time.
Yeah, that's true. That's true. But the one day it was, print out the big letters.
Right, and so you had to
it drew, read it as a word.
So I don't think it'll be too hard to add printing, and printing might be something we want to do for debugging.
Yeah.
But to start with, I think I would rather try to skip it.
Okay, so we're starting at 1, 1. And then we've got the formula. So there's an open space at 1, 1. So we could start with making sure that that's what we get out of the formula.
Okay. So here's our formula.
That's only part of it.
Down and grab. Well, plus the other stuff, right?
Yeah.
Okay. I use Emacs as opposed to Carol's Sublime.
TextMate.
TextMate. How do I do that? Okay, so we'll create a test. One thing I noticed that Carol and I do a little bit differently here is she starts with the test module, and usually I graduate to the test module once I've got some test-specific functions. I don't know why I do that, and I think in a bigger project I would probably start with the test module, but for these little ones I've been doing just little inline tests.
I mean, if you make a test module and mark it config test, then it only gets compiled when you're
right. So what I'm doing, and the test annotation also implicitly does config test.
Oh, I didn't know that.
So this function will only be, but it's still a little bit nicer to kind of have everything grouped in your test module.
Yeah.
So 1, 1 is empty is the idea, right?
Yeah.
So basically we want to say assert. I don't know if I actually want assert or assert equal yet. So I'll just say assert something is going to be is empty at 1, 1. I'm not sure what that something should be yet. I guess we'll say maze. Maze is empty. Does that seem like a reasonable?
You're starting with a struct already. What's wrong with just function?
Mostly because we're going to have to provide the favorite number,
Okay.
which feels like a.
I mean, that could just be a constant because presumably the office designer's favorite number isn't going to change.
So that is a thing I bet changes.
Okay.
It also just feels something that should be parameterized. I don't know why, because otherwise I feel like you just have baked it into the algorithm, to the formula.
I don't know. The way it's like if this was an actual problem and it was like, I'm picking this number because it's my favorite number and we just need some hard-coded value, like I would hard-code it. But
So
decisions.
the other thing that is kind of in the back of my head is that calculating this doesn't look like it'd be particularly bad. It's just going to be some addition and multiplication. But I also am like, it seems inefficient to calculate that multiple times. So I was also thinking about having some amount of caching, where we have a hash table or a B-tree map or something that says position 1, 1 is known to be a wall or not, or otherwise we have to calculate it, which is overkill. I don't think we need it because the function is going to be so simple, but that's my idea. So struct or no struct?
Okay, let's do struct.
Okay. So we're just going to do a struct maze. I'm going to start with just, I hate that they don't give us like any information about what kind of integer they mean whenever they say integer.
Well, they do in this one for the
They give us
coordinates.
Oh yeah, they say the coordinates will always be positive.
Yeah.
But like.
But the favorite number.
Right, the favorite number could be an integer, it could be a floating point, it could have negative.
But in most other programming languages, you don't really have to care.
Okay. All right, so we're going to have a maze.
Need a new function.
Yep. New, and then favorite number.
See, now we're going to have the favorite number like duplicated everywhere.
You
like
mean
every
like
test is going to have to, yeah.
Okay.
I don't like that.
I've got a solution for that. Okay.
The default.
Yeah.
Trait.
Implement default. What did I say? I32, and so return maze. Second. So then we're going to return maze number, and then simple default for maze. And that is going to return. What did we say that theirs actually is? It's 10.
It's at the bottom.
For example, if the.
Well, that's okay. Oh, example. But at the bottom, your puzzle input is the
1362. So there's a good reason to have it.
Okay.
2 values.
Okay, fine.
So is there actually a default value?
No.
Okay. So let's get rid of that then for now. And so
we're going to start it with 10.
This one is 10.
I'm assuming in their sample thing, 1, 1 is also empty. Let me just check that real quick.
1, 1 is a dot, and open spaces as dots.
Wait, why do they have zeros if we're starting at 1, 1? Is that just where we walked in?
You can always, oh, yeah. It's an elevator.
No, what?
The elevator comes up into the middle of the floor.
No, go back to the story. You were in a small waiting area at 1, 1. But like, is the 0, is that like the outside wall? Cube maze starts as, okay,
That's
whatever.
Fine.
Okay.
It's fine. All right, so we've got that, and then what do we say? Is empty. And this is going to just return a Boolean. And we'll just start with that. Okay. Where's that on the side?
Let.
Oh, did I?
Maze.
Normally,
Someone's been writing too much Ruby today.
that's true. Normally my test thing is on the right, and I don't actually know how to move it over there. Okay, so maze is empty. Oh, right, so we want to give it some coordinates. So we'll give it an X, and
These are unsigned because they can only be positive. I don't know if that'll make it. Oh.
so I'm not really going to give it a different type. I'm just going to do a type alias.
Well, but why aren't you connecting them together then?
What do you mean, have a chord that is a
XY
tuple?
is the point. Mine should make a point.
Okay.
I'm just saying if we're gonna abstract, like.
Well, that's the thing is I didn't really want to abstract. I just wanted to.
But you're doing it anyway. No one's forcing you.
I wanted to make it so that if I change to a different size, I only had to change one thing. Which I guess that's
And
abstraction.
see now I want point to be a struct so we can say point.x and point.y.
Okay, so what you're saying is I shouldn't do any of this. I'll just hard code
Yes.
U32 here,
Yes, please.
and then hard code U32 everywhere through the app.
Yes.
Okay.
Just that one spot.
All right. So unused.
Because we said false. Okay.
Okay. So if we paste our here, and okay, so that's our basic number here. And then we're going to add the favorite number. So a lot of times I do this thing where this is a bad name in this case, I just kind of use temporary variables because I don't know what I want to call them yet. I pick easy to replace variables. So then we add them up, and then we want to know, count the number of bits that are 1. The number of bits that are 1 is even. It's open.
Now is there a standard library thing for this?
There is, actually. So each number has a method called count ones, which happens to return the number of ones in the binary representation. This is one of those things. This is actually very cool because LLVM will like optimize that very aggressively. So we want to do count ones, and we want to know if it's even. I always feel like that this should exist, but there is no even predicate. So we just, if it's even, then it's an open space.
Okay.
So that should actually be fine.
Run it.
And this will not run because we don't know enough about our magic number yet. So I'm going to.
Yeah, just make it U32.
Okay. So that passes. Now, as Carol was committing frequently, I tend to commit very frequently, but not push up all of those little things. So we'll just say first test here. I tend to have very silly, tiny commit messages because I know that I'm going to roll them up and give a better commit message anyway. Okay. So now, before we leave this function, names for these variables. So like nothing really came out. It was just kind of like.
Yeah, there's like system and formula. If we want to pick some words from the domain. I don't know.
I mean, like, there's always I could just call this sum, because it is, and that's basically the only word that they say. Add them. And then this is just like,
Sure.
Like, there's not great names, but they're at least better than XXX and YYY. Okay. Compile, still compile. So what do you want to do next? Do you want to do some more points?
I think we should test for a wall space.
Okay. So there's a wall space here. Do you want to do that one?
Yes.
So
I think it's 0, 1.
so we think x is 0 or y is 0?
X is 0.
Interesting. So that's good because in this case, we'll know because if we get the coordinates wrong, it'll be
if we look at
backwards.
if we look at the next thing,
Yeah,
it's
I was
wrong.
pretty sure that x was horizontal, but the good thing is this test that we have because the diagonal.
Yeah.
So we should say that this one, which is going to be, I think is going to be x is 1, 1, 0. That is a wall. 0, no,
No, you just said 1, 0.
1, 0. Insert not. Does that ever get merged?
I think it's just any.
Any?
But that's not equal.
Oh, right. Don't want equal. Okay. So run the test. The pass.
Okay.
Just for my own curiosity, make sure this does. Okay. Cool. All right. So we got this. Okay.
So now we have to do the pathfinding and traveling.
Right. So we want to do the shortest route.
That says to me another breadth first search, like the elevators and the generators and microchips problem.
Right. So the general structure for that problem was we have a queue. The queue contains potential solutions.
Mm-hmm.
We pop something off of the queue.
We try and take another step.
Yeah, we have many steps that are possible.
Yeah.
And sometimes some steps are not possible. So in this case, the ones that aren't possible are walls.
Mm-hmm.
And then we put all the possible ones back into the queue.
Mm-hmm.
And this might be a little bit of Yagni, but like when we did that one, a couple things that we learned were we definitely want to keep track of where we have already been.
Mm-hmm.
And that avoids just doing a lot of extra work.
And we definitely wanted to avoid putting duplicates in the queue and not deduplicating until you pop them off the queue.
Right, because again, that causes just a lot of work you don't need.
Queue really long.
And then the other thing is go ahead and check and see if you've reached your goal before pushing it on the queue, because otherwise you push the answer into the end of the queue and then you have to process thousands more of potential nodes before you actually pop it back off and see that it is the success. So we're not going to do a very small step here, it feels like.
No, I'm trying to remember how I mean, we could do the step of, given a location, like what are the possible next steps from that location?
Okay. So test here. So we've got our existing maze here. And so we could pick any spot on this chart, and then we can just look left, right, up, and down. So we know we've got some issues around the edges, because we can't look left from this edge and we can't look up from this edge. The other two edges, it's fine, because basically we can get to the upper limit of the U32 before we hit any issues.
But let's just pick a spot in the middle that has some empty and some wall.
Okay.
And check that we get.
So that spot right there has two walls and two empties. 3, 3.
Okay. I can't see.
Yeah. Okay. So we want to say at 3, 3. The maze next steps at 3, 3. And so equal.
See, don't you want a point class now?
I don't know. Oh, you're
you
saying
say point. We want to get a vector of points back, basically, and we want each of those x and y's to be connected to each other.
right. I mean, that's could also just be a tuple.
But then you have to. I already messed up once, which was x and which was y.
I don't think that that would have been solved by the struct because you were assuming that this direction meant x. That wasn't, you mislabeled
I mean, as long
x
as
and
you're
y.
consistent, it doesn't matter.
Yes, I guess. Because then everything would just
But
be
the
mirrored
x
on
and
the
y,
diagonal.
the x and y, make sure that you're consistent.
Well, we're in the middle of a thing now, so either we abandon that and refactor, or we do this and then refactor.
Let's do this and then refactor.
Okay.
So we want a vector of the open spaces only.
Why do we want a vector here?
I don't know. What else would there be?
I'm just saying you can compare a vector against an array.
Oh, okay.
So, and we decided.
I'm thinking about the return type of the function.
Right. So 3, 3. We decided that if we look left, that should not show up because that's a wall. If you look right, it should not show up. It's a wall. So we want x is 3, and then y is going to be 2 and 4. Does that sound right?
Yeah.
Okay. So we want 3, 3.
No.
That's what we're currently at. 3, 2, and 3, 4.
Yeah.
So something like that. Okay. And test this. No method named. Now, one thing that I'm already thinking about this is that we've picked an order. Like, we don't actually care about which order it is. So yeah, so we might want to change this to a set. I'll go ahead and add the method though. Next steps, self, x u32, y u32. And we'll start by returning a vec of u32, u32. Okay. And we'll just we'll do an empty vec. Test run and fail. Okay. So insertion failed, left was empty, right had stuff in it. So basically we want to be able to say, we want to look at each of the 4. So we want to do
-1 and +1.
Right.
For each direction.
I have been doing Ruby too much today. For x delta in that, or y delta in that.
I think you're going to want these to be maps in like a minute, but okay.
Probably, yeah. Okay. For each of those, then we want to do self is empty at
X plus x delta, comma, y plus y delta.
that, and if then result push. I actually want that value, so if that one is, then the tuple of that. And okay. Do iterator is not implemented for that. That. Okay. So this is kind of similar to something that we ran into with the
problem yesterday.
The problem yesterday, because we really want to have unsigned numbers, and we want to apply differences to them. So one thing is, like, if we knew that we were subtracting, like this value could be a 1, and then we would subtract instead of adding. Like, does that make any sense what I'm trying to say? Like,
no.
like you can have a U size and you can subtract a U size from a U size. That's fine.
Yeah. Well, then why, instead of doing this, why don't we say, like, x deltas, let x deltas equals array x minus 1, x plus 1.
So like this. So instead of delta, we actually just have x's.
Yeah.
Okay. So like that for x, for y, and then that's going to complain about references. So we want our dereference here. Okay. So that gave us back, interesting. It gave us back.
Are we doing the diagonals by accident?
Um,
Or is it the opposite? What? I don't understand what happened. Oh, we're varying both the same time. We only want to be varying one of them.
oh, so like if I were to
Yeah, our loops are
move
nested, but we don't want them to be nested.
this. So something like that.
I think so.
Okay.
There we go. Okay.
Okay.
And the ordering happened to be.
The ordering happened to be the same. So let me go ahead and commit that. Oops. All right. So now we have basic next steps. All right. And so we had a couple things here. So one was, you mentioned iterator type solutions, which I'm a big fan of, especially considering that we've got some redundancy here. You want to try and do an iterator version of this?
Sure.
Okay. Any ideas?
No. I want something that we can filter on is empty.
Yeah.
And then just return the results of that.
Yep.
But generating things that go into there.
Basically, we know that we kind of want to have this XY be our iterator item.
Mm-hmm.
So, and we know that this is going to be how we want to start. So we get rid of our fors here. And then we'll call it iter.
Itra.
And then basically we've got a value of x. We want to create comma y.
Mm-hmm.
And then I'm just going to kind of move all this down for a second here. So then we want to do the same thing here. So we're going to say y iter map y xy. Now we've got two iterators that return the same thing. So then we can say chain them together.
Mhm.
And then, like you said, filter tuple of X and Y, and this will be a reference. We want to, this is my pet peeve, the filter keep that or not?
Yes.
So it keeps the ones that are empty, which is not what we want.
No,
No,
it is what we want.
it is an accept. So filter the ones, okay. So keep the ones that are empty,
Mhm.
and then collect. All right, that's not like that. Expected U32 found
And there's
a
a
reference.
reference in there somewhere.
Yes. Oh, these are references. I forgot to copy that from the loop.
It's better.
Operators now. And
We want to change to a set.
probably. The annoying thing is going to be that there's no nice hash or no set literal.
Mhm.
And this is kind of where I start to like think about maybe having test specific module and function, because what I might actually do, well, here, we'll do it in line first. So I might actually take something like this and got this, and then I might take iter clone each element, so it's no longer a reference, and then collect it into a, I'll just say B-tree set, because we've been using those a lot.
That's backwards.
Something like that. And then I would say expected here, and that should fail for lots of reasons. Okay, so use standard collections.
Putting that in the middle, huh?
This is something that it's weird that I do, because it's bitten me before where I've forgotten that I don't really want to do that, and then forget to move it up. But I tend to type it right there, right when I'm starting. Okay, so now it's complaining that we have a vec. So I will change this to the B-tree set. We're using collect and just magics it for us.
So now we should be able to switch the order of those tuples, and the test should still pass. Do you want to check that real quick?
Like these tuples here?
Yeah.
Okay.
Cool. So now we've got some literal edge cases that we should handle.
Okay. So do we want to pick one of our examples here? So which edge would you like to examine?
I mean, we could do 0, 0.
That has the most number of edge cases?
Yeah, so
both.
it depends how big of a step we want to do. We could do something that's in the middle, so like 4, 0, so that there's only one edge case. We could pick 0, 0 since there's 2 edge cases, but they're kind of the same edge case because they're both at the low end of our XY ranges. And then I think there's a fixed size for the, no fixed size?
I think it's infinite. So I mean, in our...
Oh, extend infinitely, okay.
Now
okay.
in our implementation, it is a fixed size. It is, U32, so
yeah.
There is a limit. A very, very robust program would probably want to check for that, and maybe will magically do some solution that works well for that, but
Or maybe we'll put a whole bunch of stuff on our queue and crash our program eventually.
Yeah.
I'm okay with letting that crash.
so let's do 0, 0.
Okay.
So 0, 0 has a wall to the right and no wall. So the expected answer would be at x0, y1, there should be 1 open space.
And it shouldn't panic and it shouldn't tell us that we can move to -1 and 0 or anything like that.
Right. So x0, y1 is what we expect. Right? Yeah.
And I put
And
it 0, 0.
0, 0. So now we definitely expect this to crash. Attempt to subtract with overflow. Okay. So if we go to line 21, so we've got our
Saturating
nice.
sub.
So yeah. So we got all the saturating variants. So saturating sub is going to subtract the two values, saturating at numeric bounds instead of overflowing. So,
But that still means it's going to check and try to compute. So like we take 0, 0 and we do saturating sub 1, we'll get 0, 0,
Correct.
and we'll compute that and do extra work, and we don't want to do that.
Right.
We want to toss it out.
So there's another one. So there's check dead and check sub, which return options, which would be nice for our filter.
Flat map.
Yep. And then there's also overflowing. There we go. Overflowing variants that actually return a tuple of the value and if it overflowed. And so if it actually overflows, the value is just like whatever the wrapped value would be. So there's rare cases where you want that. I'm actually remembering because when I did my implementation of yesterday's project, I used overflowing add, even though I don't care, and I should have used
Saturating.
Nope.
No, checked.
So
yeah, I can never remember all of these.
Yeah, I come here and I have to like find all of them.
Yeah, let's use check sub.
And so we can do x checked sub 1, because that does take the actual, yeah. And then, because we're here,
Yeah, hey me.
I'm going to not
Check
sub.
add.
Okay. And then for each of those, we're going to flat map. This is where we want like ID operator, because we don't really care. Checked sub of 1 and the checked add of 1 iterator and flat map of y. File and tests.
Yay!
Pass. This is kind of a wall of code.
Yeah.
Like looking at that.
And like there is some duplication. Like the first 2 lines are basically the same.
Yeah. So
it's kind of like find adjacent.
one thing that I would probably do to start with is pull this value of the chained out and just give these 2 variables, because this also helps prevent some of the crazy nesting.
You've got 2 dots now. Made that dot chain.
Oh yes, thank you. Great. Always gets me. Oh right, because I am iterating over. It's actually surprising. So I create this array, and then I'm iterating over it, and it gets dropped, which is fine. because I should be ending up with, oh, it's because the actual iterator is trying to rely on it. That's annoying. So the iterator has a reference to that array that's created and then immediately dropped.
Okay, so we're gonna have to collect, or
I would avoid the collect, and then I would probably do something like this, where basically I go ahead and do exactly as the compiler asked, which is introduce a let, even though I'm like shadowing them.
okay,
Now the thing that's tricky is because you mentioned there's some duplication here.
yeah.
And
I thought we could just pull that whole thing out in a function, but no. But then that function would have to return an iterator.
And the other trick is that it's actually different here because like, or I guess really it's in here, because this y and this x are like different, and so you'd actually have to provide the x and the y for the other way, and you'd have to know which one.
No. Okay, I mean, this is better.
So we just call these x's and y's.
They're not really x's and y's though. They're x varied and y varied. Because the x's contain the y as well. The points.
Oh, yeah, okay.
Points with x varied.
There you go.
That's kind of long.
I mean, it is a little long, but it's actually not terrible. So this line is still 96 characters, which is a little bit longer than you want it to be. I think that's okay.
All right.
Add that. That works. Okay. So now we've got our next steps.
So now I think we need to take a big step.
Okay.
And just start the breadth first search.
Okay. So we know that we want to reach 7.4.
And we have a starting location.
And we have a starting location, which is 1.1.
Mm-hmm.
It's always 1.1, presumably. That could be a thing that they change. And we know that it takes 11 steps. So shortest path. So we're going to create our maze. And then we want to say maze. Oops. Maze shortest path. 7,4.
Well, you have to specify starting location too.
Oh, I think that you always start from 1.1.
But we didn't even hard code the secret number.
But we know that secret number changes. It's 10 here, and
Okay,
it's
fine.
1362 here. All right, maze shortest path.
Sort equals well then.
And this will fail. So I've got no shortest path. Shortest path. And this is going to take self. It's going to take an x, which is a u32, y, which is a u32, and it's going to return, probably we'll say u size. Okay. Find out. 0.
So we want.
Does compile, but yes. Okay, so we want.
Want a queue. Let mute queue. We used a vec deck in the other one. That turned out to be pretty good.
And we like that because it's actually a queue.
Lets you add to one end and
Pop
remove
from
from the
the
other end.
Yep.
So we want to, well, we could, we want to start our loop. So we could just check and make sure that like we have our starting location of 1, 1.
Right.
We said we wanted to check and make sure that we're not at the end, like as soon as possible.
So you want to say like,
But I also
if-
want the loop to be while the queue isn't empty. And then immediately check to see that we're not at the end. So, I mean, I guess pushing 1 and popping 1 is not.
what I'm hearing is that you want to do this. If x equals 1 and y equals 1, then return 0.
What I
Like
Sure.
it's a special case that basically you want to
but
avoid,
like,
and that you're worried that this is not going to be duplicated down there.
yeah,
But like that.
okay.
We'll see if it fits in nicely, because like you're trying to like contort the logic a lot to handle a special case. It
And
feels like.
I'm jumping ahead because we just basically did this problem a couple days ago.
So we're going to push our starting position into the queue. And then we're going to, while there's stuff in the queue, just gonna go ahead and,
Yeah, you wanted to call it point.
I was
Saw
thinking
that.
about it, and then I realized that I don't need those names. Queue pop front, because it's queue. Okay. And then basically we want to say self next steps of x and y.
We're also going to want to know how many steps we've taken and keep that on the queue with the value. It'd be really nice if we could have a couple of point and distance, point and number of steps.
I said we can introduce a point.
Like half an hour ago.
I said either this or that.
I didn't have enough evidence then, but I enjoyed
No,
pointing out all
after
the
the
evidence.
after the last function we were doing, I said, do you want to do this or do you want to introduce a point? And you said, let's do this.
Okay.
Do you want to stop doing this and introduce a point?
No, not anymore.
Okay. Do you want to wait until the next time that we need a point and then bring up that we need a point? Because that might make me introduce a point now.
Okay.
Do you want to just do a point?
Yeah, comment all this out and let's do a point. Passing tests.
What do I want to do? Oh, that's why. I have multiple key bindings that conflict. So I'm confused. Okay. Tests. All right. Passing. All right. So you would like to have a struct point xy, right? So you want u32, 32?
I mean, that's not really what I want. I want .x and .y on it.
Okay, so we got x, y. That's what you want.
Yeah.
Okay. I'm not going to type that everywhere. Impl from u32 4-point function from other u32, the rarely used
Destructuring in the arguments.
Yeah.
Fancy.
Self. And then because we're going to be fancy, so Carol and I both run nightly compilers, which means we can do this. All right, that compile. Nope. Right. So we want to add this feature flag. We do this so that we can find strange cases in the future. Okay. So we've got that. And now we want to basically find everywhere that there's a U32 almost. And
Yeah, but like not everywhere. Like, but there.
we want there.
Mhm.
So we want XY, the point. Oh, I can't do that anymore. Point, point. Now what? You want me to type point.x in each of those places?
Yep.
No, you don't.
Fine. No, backwards.
Okay.
Okay.
It'll work. It's gonna fail, but okay. Same thing here.
Yeah.
Point. Point. And then you want me to put
Yep.
it here and here
Yep.
and here. Nope. Point. I mean, if nothing else, doing it this way would be a very good way to make small changes so that we're not doing a whole lot of changing. So still complaining that we have to change all these. All right, so
I think it's also complaining about the one in the filter.
filter.
Go check the error message again.
Yeah, just typing this here. Okay, incorrect close limiter because I just typed something wrong. Okay. And now that doesn't go there. Okay, this function takes one parameter, but two parameters. Oh, okay, I see what you're saying.
Yeah.
So now we need to convert, make a point I, which is what we want to return here. So I'm just going to go ahead and move this map call up. And then filter point. Endpoint doesn't do org yet because
You're doing it on maze?
yeah. I almost always try to do debug on anything at any time. Maze doesn't actually feel like a value type to me, so that's all I'm going to put on it for now. But this feels like a value type, so I'm going to put all sorts of, and what do we need?
You need a word.
Partial
word.
Word.
You may as well put econ.
You have to have a word. Okay. And then our tests. So point I and fail 4. Okay. Point X Y. Okay. So same problem here. This is something I actually wanted to clean up a little bit because we copied and pasted this implementation. So I would probably want a little helper function that returns a tree set of, we know it's a point in this case, and which is nice because it also means we can get rid of explicit type there because it's now in the function. And this is going to be a thing because we'll be fancy. This is generic. Let me some generics. I can be into iter or into iterator. And then item is going to be something that is a
Into point.
Yeah. So then we need to actually do where I into iter and I item implements into point. So then we can call I dot iter to iter map into collect. This can just be that. This is not going to, first time I can tell you that. This will be, oh, that function should not be called x. It's going to be really hard to rename x all up in this code.
I could have told you that.
So we'll make it something more unique, 3 x's.
Why not poop? What's wrong with poop?
That's inappropriate.
That means you'll change it before you push it to production.
Oops. I don't know if anyone else has this problem, but I do. I put that colon on a variable declaration so much. It must be into iterator. Our iter, rate bound, blah, blah, blah. It's not an iterator. Isn't.
Yeah.
Okay. And the point can be converted from a reference to a tuple. How lazy do I want to be here?
Super lazy.
Okay. All right. And then next steps, point x, y, and
And can we change x like this to something else?
yes.
So that is also not appropriate.
This is where I would introduce the
Test module.
yeah. Test. Right?
Mhm.
Okay. The other thing about this is that this is going to trigger me to actually make things public, which is another benefit of doing it. I call it points instead, just because it's kind of a little function that gives us points. All right, and now we're going to use super, and then because I haven't made anything point or anything public, I tend not to until I need to.
And we're going to need beach reset, yeah.
Okay. All right, so test passing, so we'll go. Here. Code. Point. Okay. So now like this, and this function is going to want to take a point. Point x and the point y. As we're going to push the point. Point. Steps in. Point. some
More
point,
points. Yeah.
then I know this isn't quite right, but push back. Okay. And this needs to be point x and y. I think we're more or less back to where we were before.
Yeah.
Okay, so no vecdec and mismatched points. Yes, okay. So we'll go ahead and include vec x. I don't know, does Rust format alphabetize imports?
I don't know. What did you do?
It doesn't actually, it only formats correctly when your code compiles.
Oh.
Problem is
Yeah,
right
but
now,
returned.
yeah. That's an infinite loop
Yay.
because we don't have any end condition.
Yeah.
What's the name of this?
Twisty
Twisty.
little cubicles.
I'm pretty sure that the Emacs cargo thing actually has a way of doing this. I just haven't looked it up.
Okay,
So infinite
let's
loop.
not run that again until we have a better stopping condition.
Oh, why doesn't it? I can build it without it as well. But it doesn't want to format right now.
It's okay.
Okay, so we've got, your point was that we don't actually want to push the point on because the whole idea is that we need to know our depths.
Distance, yeah. So we want to push the point and the distance. And the initial one is going to be 0.
Right, so what would you call that? A state?
Sure.
I'm just going to, for right now, just do this right in line. So it's going to have a point and a depth. So that's going to be a point and usize. And instead of pushing a point, we want to push a state with a point and 0.
Yeah.
Okay. And here we want to pop off a state, which has a point and a depth. And we're going to push a state with a new point and a depth of +1.
Mhm.
Okay. And that does build.
We still haven't put a stopping condition in yet.
Right. And the stopping condition is if point equals, which now I'm going to give that a better name.
Yeah.
Then we want to return depth. This point is the, this is actually really good, endpoint, because this is not what we wanted to push.
Oh yeah, we wanted to push 0, 0. 1, 1, 1, 1.
Okay.
See, can we just get rid of that if point x1, y1? Because we're about to check that again.
We're not about to check that again.
Oh, because you haven't changed, no.
We would
up.
pop it and then look at all of its neighbors.
But weren't you saying that when you pop something off the queue, we should check right away? Oh, you were saying before we push
Before we
things
push
on.
it.
Okay. All right. Okay. But that if statement, we still need to change it because that is saying point, and we just changed that to endpoint.
Yes, the if statement, right? Endpoint. And
No, the other if. Up like 5 lines. That.
Oh.
Yeah.
They both need to be changed.
Yeah. But you didn't change the one I was talking about.
Okay, so that compiles. Now I'm just going to do this, which is initial point is going to be a point of x1, y1. And if
What? Okay, it's constant.
I put the type,
Yeah.
yeah. So it's that, and then
Okay. We're still returning, well, the 0 is like if we exhaust the queue.
Yeah. So really, we could do two things, and this would be my preference. We could make that be unimplemented or unreachable or something like that, but I actually think it should be an option. So then I would say this. Basically, we exhausted the entire thing, which is basically impossible because we're not going to go through the square of a U32
Yeah,
in our lifetime, but
we might hit
we
all
could have
walls.
walls. That's a good call. That's another thing I've noticed about some of these problems is that like there are error cases that Rust makes you think about that don't really get explored by the problem definition. So, okay. This is very silly, but just for parallelism, I want to have a little thing here. Because the hard-coded 0 twice made me.
Run the test, run the test.
Expected type. Oh, right. So our test is.
Thanks.
Filing.
Womp
Failed.
womp. Off by 1.
Okay.
So I guess they're counting. Should we start at 1?
Let's take a look and see what they've got. So it's the path length.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
So there are
Like
11
the
O's.
last step.
I wonder if it's because here. Yes, that's why. Because I'm returning depth here,
And we've
but
actually
really
taken one more step.
it would have been depth plus 1. So pop it, and then do we actually need this depth anymore for anything? What about that?
All right. Okay.
And then our main test is going to be these two things. The main, oops. Main. So we are going to have a maze with this magic number. Maze dot paths 1 and 39. Just thinking about it. So I'd probably instead of that, I would probably running release mode. So we talked about this earlier and then didn't actually implement it.
We didn't look for duplicates and caching of.
Yeah, so that's a little bit slower than we want. So
Yeah.
we know that we've got the immediate benefit thing that we can do, which is in addition to our queue, have a list of things that we've seen. And this will just be another B tree set. And basically every time we push something into the queue, we say,
before we push it.
or yeah, before we push it. So we say if scene contains, I always get this one wrong.
Yeah, but we want if not contains.
If it doesn't, yeah. Then we want to scene insert, right?
Yeah, and we should put the initial point.
Scene insert.
Can
Still
we
compiles.
print out our queue size at 7 points?
Okay. Any idea how frequently you would want that to be done?
So what I did in the other problem was anytime we changed basically what is the depth here,
Mhm.
Print out some status. So I'd keep like a running.
Okay. If X scene not depth, right?
Yeah, sure.
Then max depth scene equals depth. And frontline at depth blah, queue size is blah. Like that?
Yeah.
So we've got depth and queue. That?
Yeah.
And oh, yes, mutable will be important here. Okay, that was all it took. We're finished.
Oh, okay.
Scene was very important. Now we've got the path was 82.
We think.
We'll find out.
Yay!
All right.
Okay, what's it gonna be?
It's okay. Part 2. How many locations can you reach in at most 50 steps?
Okay. Do you really want to keep this code doing both things?
Well, what do you think the change will be?
So we have the scene. That's
The scene is the count, right?
yeah. The scene is the locations, the
Right.
distinct XY coordinates. But well, I guess it's just when the depth reaches 50, we stop the max depth.
That's our new stopping condition. We just go until the max depth, which we happen to be tracking now,
Mhm.
goes to 50.
And then print out how many are in the seed set.
Okay. So
we could just add some printing, but we have to like the
what I've been doing for things
endpoint
like
that
this,
we give to it has to just be like
very far away.
yeah, size max or whatever.
So what I've been doing, and this is one of my favorite things to do in programming, is copy and paste code. And then change it. And then see what similarities there are.
Okay.
And then extract those back out. What would you call this? It's not the shortest path anymore.
It's like unique locations in a number of steps.
And we know that instead of endpoint, we really want to say within some number of steps, right?
Mhm. And we still want
That's
view
all.
size, but not rows to have, yeah.
Okay. Keep our statey type stuff here. The initial depth is interesting because
It
that
did
should
say
be 1.
including, it said including your initial location.
So this should be 1, but it's not initial depth anymore, right?
Yes. So I,
Like we could keep this.
but like the if condition's wrong.
Oh, good point. The endpoint equals, yes. Okay, I'm just gonna delete that then.
Yeah.
Okay.
It's like if the number of steps is 1, then return 1 because that's the only place. Well, not 1 with, if the number of steps is 0, that's the only place you can go is the initial point.
Right. Which I think will be covered here because the max.
Should we write a test for that?
It's interesting. I feel like on the second part, I tend to write less tests because usually it's some slight
Just tweak it a little
variation,
bit.
which doesn't actually mean that it shouldn't have tests, but
Mhm.
they actually do give us one. No, they didn't. Okay. A lot of times they're actually like, for your example
Yeah.
problem, the answer is X. Guess not in this case. Okay. So we put our initial point in, we put our initial depth in, and basically we don't need max depth seen anymore. It's when the depth
We've just popped off.
is greater than number of steps. Greater than or equal.
I don't think we want equal because, so if we have, we're gonna have a whole bunch in the queue that like take 10 steps. And we don't want to stop on the first one of those because we could reach in 10 steps any of those. We want to stop on the last one.
Okay. So it's not inclusive then?
Yeah.
Okay. So if the depth is greater than the number of steps,
Then
then
we want to return scene length.
Okay.
Yeah.
And then everything else is the same, I think.
We want to take out the if point equals endpoint because we don't have endpoint anymore.
Oh, yes, there's no end state other than what we already have.
And then we want to change name to call this.
What about this none? This should actually just be return scene line.
Yeah.
Shortest path, locations within steps. And
50 steps.
And 50 steps. There are
I'm really feeling like we have an off by 1 somewhere.
Probably.
Want a semicolon again there?
Okay. McMahon didn't go into another infinite loop. We still have our debug printing. In 50 steps, there are 139 locations.
Okay.
In the chat?
Yeah.
Oh, the answer's too high. Okay. All right. So one thing that we can do is we do have this graph, and so we can write some tests. So we know that we say within 0 steps, it should be 1. And within 1 step, it should be 1, 2, 3, for example.
Wait, where are you getting 3?
Oh,
the
this
original.
this spot, and this spot.
Okay.
So let's write some tests. Steps. So maze locations within steps. So I said that 0 steps should be 1.
1.
Go ahead and make sure that that happens. Okay, well, that's a good. Left was 3.
Okay, so there's our first software one.
Yeah. I think that. Okay, so what happened here? We said within steps. So locations, which that is a bad name because it's locations within steps, not.
Yeah, I think you did a primary place.
Oh, I thought it was more. All right. So steps. So if the depth is greater than the number of steps, which it is not when we start.
Yeah.
Which is right. That's correct.
So in the other function, we have a special case for the first thing, and then we took it out.
That's true. One thing I just saw though, we're inserting things into the queue before we visit them, which means that the queue has a giant backlog of things, as does scene. Scene actually includes things that we haven't visited yet.
Ooh. So we need another scene. We need like visited. Ah, fancy.
Yeah. I don't think that'll help our test though.
That was one of them.
Yeah, so it changes from 3 to 2. So why would it be 2? So we start here, and I think you're right that it's probably something like we probably want to add that special case again. But so if it's 0, we push it into the queue. Then it says depth is not greater than steps, because steps is 0 and depth is 0. Then, so it doesn't break, we increase our depth because the next set of things are all going to be at 1. So we say insert point, and from our starting point, we said there should be 2. There should be 1 to the left and 1 down. So it inserts 2. Oh, okay. Now I know why it's off. It's because we've popped the failure 1. So as a quick hack, just to see if this continues to hold. So this should cause that first test to pass. It's definitely a magic number, so I'm just going to write magic for a second. What's our no, 1 step? We believe that should be 3.
3, yeah.
Okay, and then within 2 steps, we've got 1 step. Can't highlight that for some reason. There we go. 1 step, 2 step. So those 3, 4, 5.
Yeah.
Okay. And then that is capped. So at the next one, it's going to be 1, 2, 3, 4, 5, 6.
Okay.
Ooh. Yes. Okay.
Okay.
And then just because it's here, the next one is going to be +1, 2, 3 on that. This will be 9, 4. Okay. So how do we want to make that code better?
I mean, my initial reaction was we should have two sets, one that's seen and one that's visited.
Okay. So
That's like storing
right.
double amount of stuff.
So I mean, the code that's there.
We could just name. We could say let seen not within reach equals qlen -1. So that at least names that a little bit.
You're going to do the same thing, but a little bit different. Because
We didn't really visit the last thing. It's like we considered it, and it's not on the queue anymore. I don't know. I kind of want it to be like the one we just popped off the queue.
yeah. Which I would normally actually probably like the seen but not visited. Well, not considered. I like the considered word. I would probably do that. Seen but not considered. And then I would actually probably just say the -1. And I would have a comment that says, you know, we popped
Yes.
we popped one off the queue and discarded it. Ooh, discarded it. Now, the other thing we could do here, which is a little weird,
We could push it back on
we could push it back on the queue. But then we'd have to have a comment there.
Yeah. I think this is fine. I think I want to run it in Seaver right now.
Sure.
Can't handle it in suspense.
Okay. Seems. Are we off by 1? That's gonna make me mad. So it actually wasn't anything on the queue.
It was just the initial state.
It was just that there was nothing left on the queue. It's just that we hadn't popped the 1. Oh no, you're right. It's probably like the first thing we did. Anyway, we got this.
We did it.
We did it. All right.
Thank you for anyone who watched all this way.
Commit this. Commit part 2. And take one last look at the code. All right, so there's a couple things that I would probably continue cleaning up. I don't actually like defining a struct or consts inside of a method. I'd probably go ahead and move that out, especially considering that the struct is shared here. This initial depth is also, and the initial point are also used. There is some other stuff that's common here. There's the setting up the queue and popping it off the queue and then iterating through it. If I was
To like
feeling
make that a closure.
if I was feeling really fancy, I might. I don't know. Like the problem is with just a closure, you kind of want just one closure per function call. Like
Mhm.
you don't really want to pass two closures. At that point, you want to like have a trait and give names to it and stuff like that. And I'm trying to think like what would I call this? And then like the other thing is like there's kind of like what you return is a little bit different in the
Yeah.
middle. So I don't know. One thing that I could see is like perhaps wrapping this kind of code and maybe like this code and the while loop into a new struct. And basically all that it does is it continuously iterates through stuff and adds it to the queue. And then maybe all you care about is,
Like returning the whole state of the world,
yeah,
and then you can examine whatever you want out of it.
yeah.
And then all you would be specifying at that point is your stopping condition and your closure.
Right. But actually looking at it now up here in this one, we do the stopping point inside of the for loop of the next steps. Whereas down here we do the stopping condition outside of the for loop. So I don't know how much of it is actually savable or reusable, I should say.
Wait, say that again?
In
The
the
4 point ins next steps point, right?
yeah, here we do the stopping condition inside that.
Right.
But in the second function, we do it outside of that. So you
I feel
couldn't.
like we could move it in there if we really tried, but we might be contorting things a little.
I thought about that a little bit. The thing that I don't know how you would do off the top of your head is like, you don't know what the next thing in the queue is going to be. So like you don't know if the next thing is still at the same depth level as the current one.
Yeah.
So yeah. Tests I think were okay. So not too bad. 200 lines of code plus half test, half code. But yeah. Anything else to say?
Nope.
Alrighty. Well, thanks for watching, y'all. And oh, I gotta figure out all these windows again. All right.
Bye when we figure out how
Yeah.
to quit.
There we go. This window. See y'all.